Hi, sixth grade. I just want to go through what we're going to do today and then do a few notes in your book and introduce the lab that you're going to work on your own. Um, I should be also on the Google Meet, so if at the end we have questions, I'm happy to answer. Otherwise, Mrs. Malouf can answer your questions. So, in terms of what we're doing today, if we look at our Wednesday classwork homework board, we are going to highlight the remaining section in 3.1, which is pretty quick. Then, like I said, you're going to complete the Gizmo identification lab, and I'm going to walk you through one activity of that so that you're comfortable with it. And then if you finish all of that up before the end of class, you can work on your study guide, which again, remember, is due on Friday. So if we go to the book images, go ahead and open your book up. Let me bring those up. There they are. So the last few pages we were going to do is 106 through 109. Mrs. Malouf should have checked to make sure that you guys did the outline that I had assigned on Monday. And so quickly, let's just go through and make sure you have highlighted the most important parts of this section. So we've talked about what characteristics it takes to be a mineral or to be considered a mineral. And then we talked about some different ways in which we can identify minerals using their characteristics. And now we're going to look at, well, how do these minerals form in the first place? And I've talked about crystals growing in class. And you can't really necessarily think of crystals as a living thing that is growing like you and I grow. But when we talk about crystals growing, we're talking about this formation or this crystallization process in which atoms are added onto the crystal in the same structure over and over again in a repeating pattern. And so crystallization is this process by which atoms are arranged to form a material with this crystal structure. And as the crystal is around longer, especially in the situation of a geode. So down here is an example of a geode. I think Kelly, when she brought in her sample, that was a geode. And so you have these crystals that form out of solution, and we'll get to what that process is in a minute. But they grow inside the rock, and they form these crystal shapes, these crystal structures naturally. And it's this crystallization process that causes this to happen. So when does this crystallization process happen, or in what three ways do minerals form? So the first one we're going to talk about is organic. They form organically, and like this may sound like it contradicts one of the tenets that we talked about in terms of minerals have to be formed by inorganic processes. And this is true. Minerals do have to form by inorganic processes. However, the disclaimer is if they form by inorganic processes, then they can also form in an organic way. And so the example they give is calcite. So calcite can form inorganically or not from living things, but calcite can also come from ocean animals such as clams and corals in their shell. They produce these calcite shells, and this calcite is still considered a mineral when it is in this form. So in order for a mineral to form organically, that same mineral must be able to form inorganically. So that's how we get around that characteristic that we said had to be true for a mineral or for a material to be a mineral. All right. Now these pictures, just so that you know, they are on Classroom. So if at any point you don't get it all highlighted while I'm talking about it, that's okay. They're out there. It's for you to go look at and make sure that you've gotten everything that is important highlighted. The next way that minerals form is they form from solutions. And I think we've talked about solutions in this class. But a solution, if you think about taking a glass of warm water and dumping a teaspoon of salt in, and as you mix the salt into the warm water, the salt crystals seem to disappear. They seem to dissolve, and they seem to go away. And if you let that water sit out on the counter over the course of a week or 2 weeks, eventually that water is going to evaporate, and what will be left will be your salt crystals, so they will reform. So that is one way in which a mineral can form from a solution. So what is a solution? A solution is a mixture in which one substance is dissolved in another substance. In our example we just talked about, the salt is being dissolved in the water. When elements and compounds that are dissolved in water leave that solution, crystallization occurs and a crystal grows. So they give you the example, just like we said here, this notion of salt water or salt crystals forming naturally is one example of minerals forming by evaporation. So both of these fall under minerals from solution. One way in which minerals can form from solution is by evaporation, which is the example I just gave of water or salt water evaporating the water portion and leaving the salt behind. And then the second way that minerals can form from solutions is this notion of minerals being in a hot water solution. And as that hot water cools, the minerals come back together, and they come back together and crystallize. Even though there's still water present, the water isn't warm enough to keep the bonds broken. And so as the solution begins to cool, the elements and compounds leave the solution and they crystallize as minerals. And this is often going to be what forms a vein. And a vein, I wish I had a better picture of it right now, but a vein is when you have like a stripe of a different mineral embedded in or between other minerals in a rock form. So you may have like a stripe of a metal or a stripe of gold that occurs within the rock, and that forms typically from this process, this mineral from hot water solutions that cool. And then the last way that minerals form are from magma and lava. So what are magma and lava? I do believe we did talk about this earlier on in the chapter, but magma is going to be that molten earth material underneath the surface of the earth. And then once it reaches the surface of the earth and comes out on the surface, oftentimes through a volcanic opening, it becomes lava. It's known as lava. And so when magma and lava cool, they form minerals. Magma can cool underneath the surface of the earth. It doesn't have to reach the surface to cool. As it gets closer and closer to the surface of the crust, still underneath the surface, it can cool and harden into minerals. And one of the things your book talks about is when this happens, it's going to take a little bit longer. And so the crystals that are able to grow larger. And so you're going to see minerals like crystal or quartz form this way, where you have magma that cools underneath the surface of the earth in a very slow process, and large quartz crystals are formed. When we're talking minerals that are formed from lava, once that magma reaches the surface of the earth and becomes lava, it's going to cool very quickly because the temperature change is so drastic. And so typically then you're going to have minerals that have very small crystals because they don't have time to grow the larger crystals. It just cools too quickly. And so there's going to be other minerals that form from this process of lava cooling. And then they give you a little diagram of showing you kind of where these minerals are found. And so here we are in the United States. You can see there are minerals that are found. A lot of mineral deposits are found in the Rocky Mountains. You also have mineral deposits here in the Andes Mountains along South America. So it's not uncommon for minerals to kind of be found in mountain chains. If you think about it, that's where you have layers of the earth or maybe deeper layers of the crust lifting up, and so they're more exposed than they would be if they were still underground. So that wraps up the chapter. In terms of the material covered today, just understand that there are different ways that minerals grow. Obviously, from magma and lava cooling, from minerals that at one point were dissolved in a solution but then come out of that solution, either as a result of evaporation or because the liquid gets cooled. And that if a mineral can be formed inorganically, then it can also be formed organically. It just needs to have one way that it is made inorganically in order for it to still be considered a mineral. All right, so that's the end of that. Let me see how I'm doing on time. 1 second. I'm at 9 minutes. So I'm going to pause this video. you guys can go ahead and put your books away and your binders, and I want to walk you through the first part of the lab, but I'll do that in a second video that Mrs. Maloof will start up. So before we get going on the lab, before we start the video, I want you to make sure that you have your lab opened on one side and you have the lab report, which is on Google Classroom, opened on the other so that you can see what you're doing and type your answers. Just like my screen is split here, this is how I want you to set up, and then I'll walk you through activity A.